Hello, this is Bhavik Naik, and I have chosen the topic as research and modeling on performance database of flight management system. First, I'll start with the introduction that as an indispensable airborne electronic equipment of modern civil aircraft, flight management system plays an important role in business transportations presently. With the assistance of FMS, the missions become much safer and more economical. Meanwhile, the pilot's workload is reduced. At present, using FMS is one of the basic capabilities for the pilots due to advantages of FMS. Several investigations reveal that many pilots come up with difficulties in learning to manipulation of FMS, whereas training of FMS manipulation takes over 2 to 7 months, which may cost a lot. Using flight simulators for pilot training is a better method to solve the problem, but FMS equipped on aircraft are much expensive. Furthermore, the main manufacturers of FMS come from US and European countries. Therefore, it is strategically important to develop an FMS with self-owned intellectual property rights for the civil aviation industry. Trajectory optimization in vertical flight profile aimed at reducing flight cost is the pivotal function of FMS. The optical trajectories are not only relied on the result of its optimum method but also depend on the input from associated aircraft performance model, that is APM, the operational instructions defining each trajectory and the weather data. Thus, it is an important and inevitable subject in exploitation of FMS to build authentic APM. NASA cooperates with the Boeing company in updating and improving the performance data of CTAS aircrafts. BADA, basic base of aircraft data developed by Eurocontrol Experimental Center, provided a set of SKY code including parameters of aircraft performance and running procedures. These parameters are used to calculate aerodynamic force, engine thrust, and fuel flow in order to figure out all the flight parameters needed. Reliability of optimal trajectory gained by trajectory optimization methods relies on rationality and reliability of the performance database. In this paper, data structures requirement of performance database of flight management system are presented based on the object-oriented technique and aerodynamic model. The compositions of aircraft performance database. The conventional aircraft performance database, which includes the aerodynamic force model and engine model, provides essential aerodynamic forces and engine performance data for trajectory optimization. There are five compositions of aircraft performance database. First is data format of aerodynamic data, aerodynamic coefficients calculation, aerodynamic model, engine performance data, and operation data. As complexity of mapping from aerodynamic data to the aerodynamic coefficients, it is difficult to describe relations between them using simple continuous functions. At right, we can see the table algorithm which is applied in order to acquire the necessary data in this paper. The performance database are classified by dimensions of independent variables they map. Thus, each component of performance data is regarded as a dependent variable, and then they are stored as tables in database developed. Aerodynamic coefficient calculation. The approach to acquire this consists of two steps. They are interpretation and aerodynamic data process. First, interpretation, that is for the established table, interpolating is used to acquire desired data. To ensure the rationality of results, the interval of data table can be unequal. The fundamental of the lookup table algorithm is shown as follows. Then the aerodynamic data process, which includes trajectory optimization, vertical flight profile, that is a technique of FMS. The aircraft motion in vertical flight profile refers to flight track lies in the vertical plane all the time. By removing the parameters related to lateral motion correlative parameters, the aerodynamic coefficients are acquired. These are the both formulas included for the aerodynamic data process and to calculate the drag coefficient as well as uh, to calculate both of the drag coefficients. Next is the aerodynamic model. Known for flight dynamics, the aerodynamic of aircraft reveals as follows. In both the diagrams we have defined and displayed the meaning of the coefficients used. Then the engine performance data. Measure of simulation of engine involves three aspects, that is overall performance, component integration, and integrated simulation. In trajectory optimization, the desired engine performance data refers to fuel flow and engine thrust. The simulation of overall performance is adopted. The engine performance data is stored in table format as aerodynamic performance data. The engine performance data are shown in the table which we have on the right side. Then the operation data. The operation data stored the operator during flight. Under several circumstances, the operation is standard, such as standard instrument approach and standard instrument departure. For example, the takeoff decision velocity is relevant to flight safety, is a key parameter during departure. In the database, the takeoff decision velocity is acquired from the flight manual and programmed into table format, shown in the diagram. Last is the performance data process, where the key points of trajectory optimization are selection of flight motion model and performance index to optimize. The energy state method is an efficient way in trajectory optimization. In energy state method, the total energy per unit mass is introduced and the state variables are simplified to the total energy per unit mass and displacement of aircraft around flight track. The formula is given below for the total energy. Then the performance data process. The process of performance data is necessary for trajectory optimization. In flight envelope is solved combining the thrust method and particles from optimization algorithm. According to flight envelope, under different flight states, the flight altitude is divided into equal interval on the total energy per unit mass. Simulation and result. The FMS performance database is on the basis of Microsoft Visual C++ and MATLAB or Simile. The aerodynamic performance data is acquired by removing lateral motion related performance data and processed by total energy per unit mass method. Thus, the processed data goes far towards the trajectory optimization in order to validate the correctness of data structure. FMS is run and the performance database is called. The method of database exploitation is feasible, and you can see below the uh, the screen you can see after the FMS is run. So we'll conclude by saying that the performance database for FMS is built on a source data of the flight simulator prototype database. The performance data includes vertical profile related to aerodynamic data, the engine performance data, and the operation data. In order to support trajectory optimization vertical flight process, the performance data is processed according to total energy per unit mass. Then the performance data is called by the FMS program successfully. Numerical simulation results indicate that the data structure of the developed database is consistent with the data requirement of FMS program. Thank you.